Alright, good day students. We're talking in this chapter 7 about absolute value. Now, absolute value has a very simple definition. It is the distance a number is from zero. The distance a number is from zero. So, for example, the number 9 is 9 units from 0, compared with the number -12, which is 12 units from 0. This gives you a very important property of absolute value, and that is that the absolute value of a number is always positive. Alright, algebraically the definition isn't quite so nice. Algebraically, we write something like the absolute value of x, and we use these bars to indicate absolute value. There's really two parts to the definition. The first, if x is a positive number, then all you do is write it down. If x is a negative number, you change the sign. And here it's better to think of the negative x as changing the sign. Although this isn't really important right now for our work, later on when we look at graphs and writing equations involving absolute value, this will become more and more important. Alright, let's take a look at example 2, where it tells us to write the real numbers in order from least to greatest. The first thing we're going to do here, you see we've got all these different absolute value signs, is we're going to have to actually figure out what each of these is worth. So for example, the absolute value of 3.5 is just 3.5. Alright, here we've got just the number -2. Notice, even though it might look like there are absolute value signs around it, these commas tell us that the absolute value braces go with another part of the question. So our second number is -2. The absolute value of -5.75 is 5.75. The number 1.05 is just 1.05. The absolute value of -13/4 is +13/4, which is approximately 3.25. The absolute value of -0.5 is 0.5. Here again, there's no absolute value signs around it, so we just have -1.25. And our final value is the absolute value of -3 1/3, which is just 3 1/3, or 3.3 repeating. Now it asks us to put them in order from least to greatest. So if we take a look through our list, I think we've got -2 is the least, -1.25 comes next, then 0.5, and then looking through our list, I think we've got 1.05. Let me just fix this. This was originally the absolute value of -0.5. Then we have the absolute value of -3 1/3. I think I made a mistake there. we have negative 13 over 4. Then the absolute value of negative 3 and a third. Then the absolute value of 3.5. And then finally, the absolute value of negative 5.75. Alright. Now, the next thing that we should notice is that how absolute value interacts with other operations. You can take the absolute value of a single number. For example here, the absolute value of negative 4 is just 4. We've got a minus sign, which indicates that we're going to be subtracting. And the absolute value of negative 3 is 3. Subtracting 4 from 3, we get a value of 1. Next, absolute value signs work similar to brackets. Right? We should do any operations between the absolute value signs before we take the absolute value. So for example here, negative 12 plus 8 is negative 4, and the absolute value of negative 4 is just 4. Again, we do our work inside of our brackets first. 12 times negative 3 is negative 36. 5 squared is 25. Negative 36 plus 25 is negative 11. And the absolute value of negative 11 is simply 11. So to summarize, the absolute value is the distance a number is from 0, and it's always going to be positive. If you're given a positive number, you don't switch the sign. If you have a negative number, then you need to switch the sign. All right, one of the common uses of absolute value is to help in expressing distance. Consider example 4. It says Wesley volunteers at a local hospital because he is interested in a career in healthcare. One day he takes the elevator from the 1st floor up to the 6th floor to see his supervising nurse. His list of tasks for that day sends him down to the 2nd floor to work in the gift shop, up to the 4th floor to visit with patients, and down to the 1st floor to greet visitors and patients. What's the total change in floors for Wesley that day? Well, let's quickly see what happens. He starts on the 1st floor and goes up to the 6th floor. Alright, and the distance between 1 and negative 6 is 5 units. When you use absolute value, you don't have to worry about the order in which you subtract things. Alright, next, Wesley's on the 6th floor, and he has to be sent down to the 2nd floor. And the absolute value of 4 is equal to 4. So he's on the 2nd floor now, and he goes up to the 4th floor for a total of 2 floors. And from the 4th floor, he goes down to the 1st floor for a change of 3 floors. All right, adding up those values, we see that Wesley went 5 and 4 is 9, and 2 is 11, and 3 is 14. All right, so you can use absolute value to adequately express the distance between two numbers. It doesn't matter which number goes first. You can do 6 minus 1 or 1 minus 6. An absolute value gives you the correct distance. All right, in support of this lesson, your assignment is on pages 363 to 367, numbers 1 to 6, 7, 8, 12, 14, 17, and 18. All right, remember, absolute value is the distance a number is from 0. Have a good day.